So a couple of years ago, I came across this video. It's on the cybersecurity and how the Chinese were able to penetrate different uh, plants in the states, in the United States. So let's just pick a few seconds of this video, and I will then I'll then show you what I was interested in.
December 2012. Kyle Wilhoit, a seasoned cybersecurity researcher, creates an experiment. He builds a water plant, a network of advanced industrial control systems with complicated equipment, full documentation, and a website to boot. According to the legend, the plant is located in the town of Arnold, Missouri. But in reality, it's completely virtual. It runs from a couple of machines in Kyle's basement, sending fake measurements back and forth to imitate activity. The researcher takes a deep breath and connects the system to the internet.
So that's the only section that I was interested in. So the question is it possible for us to also create a virtual plant and run our SCADA system from this virtual plant? So the idea is, because we're developing, first has to be machine learning based, because the SCADA system has full machine learning capabilities, and we want to test how it performs when it comes to the web version that we are trying to build onto it. Because we already have a desktop version, now we want to build a web version. So I've started creating a virtual plant, and the virtual plant that I'm creating is quite simple. It has 48,000 to 50,000 liters a day. So this is a dairy plant for milk, because I have happened to work in the milk factory for a couple of years. So the idea is to have two external storage tanks and three internal storage tanks, each at a capacity of 10,000 liters. So this is not currently three, it's two internal, two external, because we have tankers coming in to bring in milk. Then we have the tanker load. Each tanker brings in 2,500 liters per trip. Um, so the rest we can check as we go. So the goal that I've been trying to achieve is to build this plant. And as we can see from this, we have our tanker. So we have our tanker. So this is the feed pump. The tanker fills in tank 1 and tank 2. So those are raw storage tanks. It goes to a pasteurizer, a separator, and then the first homogenizer, and then goes to the tank 3 and tank 4, which they store pasteurized milk. So these are agitation motors. So agitator motors that are here. And the flow then goes to the homogenizer that is just before the sterilizer. And then the sterilizer feeds into the filler. So the milk is just this simple flow. So we are trying to do a simple flow. Now on the utilities, on the cleaning side, we have a CIP section. So we have warm water, alkaline water, and basically rainwater. On the utility side, we have water treatment section, we have the power section, and then we have the cooling tower and our water tower that stores clean water. We have a feed pump that feeds into the boiler. The boiler then provides uh, steam at a certain pressure to the sterilizer, so that it can uh, pasteurize the milk before packaging and also for cleaning of the whole system. These will be our pressurized air for the pneumatic systems. We have our chiller and the ammonia. So not many sections are here. So we have separated the segments a bit. So this is the analysis. We'll analyze some values over time. We have the boiler section. We can see several values for the boiler. We have the CIP section. This is still under construction. So we have the filler section. So the filler, we have a few values. So this is the pasteurized milk from the tanks, and this is how much we are filling in. So the target, the percentage so far, flow rate, the packaging temperature. On the power side, we have the electrical power distribution. So we have the main power line, and we have this is the generator. So this is the backup. Um, this is the receiving section. We'll also monitor some values on the receiving section. Shift summary. So for each shift, so we are running a 24-hour shift. So for each 24-hour shift, we should have processed 50,000 liters. But these values can change from time to time. And then we go finally to water treatment, and we'll have sections for this water treatment. So we will be building this over a period of time, but we currently have this running from our web implementation. So checking back, we can see this is our web implementation. And let's go to the dashboard. So we have this. So currently it's the simulation is running. So not all components are wired up, but we can see that so far we have processed 8,250 liters. That is 17% of our 24-hour goal. The simulation is running only for 6 hours. Um, of course, these values I have set it to 24 hours, but we will increase the simulation period for us to be able to generate more data, because the goal is to have these plant produce data for machine learning eventually. So if we can be able to create some form of a virtual twin, we can be able to create data that we can then use for machine learning. So as we can see, our tankers are coming in, but currently we only have 1,000 liters in the tank one and 1,200 liters in tank two. So of course the UI is not optimized, the design is also not that properly designed, but we will do this over a period of time, and it will take some revisions and all that. We go back to the shell, so we can see receiving side. So we have some discrepancies. For example, on the receiving side, tank one, it's showing 2,374 liters. But when we actually go to our dashboard, these values are not relating to what we have actually in the values. But we will fix that. Pasteurization side, not fully set up. So all the rest will give us the data that we need. And this is the shift production, all that information. So the goal is to create these virtual plants and see if we are able to produce actual actionable data that we can then use to train our models. So here is where we will be creating our models. We currently don't have any models to add. Of course, we have an RUL, but that is only will be used only for agitation models. So we might want to build new models like optimizer models, models that check how efficiently we are running certain sections. So all that will be done over time, and yeah. So based on these these virtual plants that we saw here, is I would like to see if we can do this in the near future.